video we'll discuss standard form of a linear equation. So the equation written in the box is your classic standard form of a linear equation, noting that A, B, and C are written as capital letters. The exercise here is to take standard form and convert it back to slope-intercept form. And slope-intercept form, of course, is y equals mx plus b. So what you're doing in the standard form, you're going to isolate y in each equation. So you turn it or think of it as a literal equation or a formula where you're isolating a given variable. So we're going to take standard form and we're going to isolate the y. So let's go through and do a few of the problems. Let's start with something like number 3. And the goal here is to isolate the y. So this is my end result goal. I would like for it to be set up as y equals. So I've got negative 3y. If I subtract x, then my next job is to divide each term by negative 3 or multiply by negative 1/3. So I've now isolated y. My slope now becomes positive 1/3 and the y-intercept is negative 4. So both equations would graph as the same line. One is given in standard form, the other is given in slope-intercept form. Let's look at number 6 together on the video. So in number 6, once again, my goal is to isolate so that I have y equal. So I've got negative 2y, subtracting 3x, and then I would divide each term by negative 2, isolating the y. My slope is now positive 3/2 x, and my y-intercept is now positive 7. So once again, both equations would graph as the same line, but they look different. So when you just look at it, it's not always readily recognizable that they're actually the same thing. And then let's do number 7, and then I would like to show you something with number 7. So number 7, once again, my goal is to set it up, or the goal of this particular exercise is to take standard form and convert it back to slope-intercept form. So my goal is to isolate the y. I would add 6x to both sides, and then all three terms are going to get divided by 4. So I now have y equaling, let's see, 6, that's going to be 3/2 x plus 5. Noting that both of these would graph as the same thing. So I'm going to leave this on the smartboard, and I want to analyze number 7. I want to look at what's happening. So if I have ax plus by equaling c in its standard form formula, if I try to isolate the y, I isolate y, my first step would be to subtract ax. And then isolating y means I need to divide each term by b, by the coefficient on y. Which means that to take the formula representation in standard form and look at it in slope-intercept form, then I can match up the slope and the y-intercept. So looking at a problem like number 7, A would be negative 6, B would be positive 4, and C would be number 7. A, B, and C would have the values that I've listed on the board here. If I were to try to match this up, the slope is represented as positive A over B. So my slope representation, and it's negative because my very first step was to subtract the ax from both sides, forcing this to become negative. So that means that if I match this up, I'm going to have a negative sign. My value of A is negative 6, and my value of B is positive 4. If I simplify that, it's going to give me positive 3 over 2, which is what I have in standard form right here. And then my y-intercept is capital C divided by capital B. Well, that's going to be 20 divided by 4, which simplifies down to 5. So to draw an analogy and make a match, that's what this little exercise is about.